So this question is a little bit involved. It's not too terribly bad, but it's a little bit involved. So it says an automobile moves on level horizontal road in a circular radius of 30 meters. The coefficient of friction between the tires and the road is 0.5. The maximum speed which we can round the curve is 1. So I'm going to say I have a center point. I know that I'm at 30 meters away, and I have my little car, and I'm going to draw the back end of the car. So it's got a nice little windshield. It's going away from us. And we know that its velocity is going to be into the page, and I want to know what's the maximum speed that I can do for this car. Now, the little circle with an X, if you haven't seen it before, just means that I'm representing into the page as the direction of my velocity. So I'm going to draw a free body diagram because that's how I do all my problems. And I know that I'm going to have a weight force pulling down. I know I'm going to have a normal force from the road pulling up. And I need a force that provides this circle. So I need a force that provides in this inward direction. And actually the reason that the car goes around is because of friction. So mu times n, or my friction force, is mu times n. So I'm going to set up a coordinate system of y and x. In the y direction, I get my sum of my forces. Sum of my forces is going to be n minus mg, and in the vertical direction, I get 0. So that means that my normal force is equal to my weight force. That's nice to know. In the x direction, however, we have to look at this and go, well, we have a positive mu times n, and this is going to provide our centripetal acceleration. So mu times n is equal to mv squared over r. And we know that the force of static friction is equal to or less than mu s times n. So I put the mu n in there. I was looking for the maximum that friction can provide, which is going to be the maximum speed we can go around this, is going to be mu sub s times n. And we know that n is equal to mg. So mu s times mg is equal to m v squared over r. And I'm going to then eliminate out mass, move the r to the other side, and I get mu sub s times g times r is equal to v squared, or the square root of that is going to be equal to v. So I do 0.5 times 10 meters per second squared times a radius of 30, and I take the square root of that. This 10 and this 5 is going to be 0.45 times, or this is 1/2. So 5 times 30, that's the number I need. 5 times 30 is 150. So I need the square root of 150. And I know that the square root of 11 is 121. Square root of 12 is 144. I approximated 10, so I'm going to say 12 looks like my right value. So this is going to be 12 meters per second.